Alright, so I'm back for round two. This is Mr. Arthur's video to go over the notes for equations and inequalities in two variables for my secondary 3 honors class. Before I start, a couple things. First of all, I am a little bit nervous about the sophomore slump. My last video was well received, so now I feel like I have a standard to live up to, and that's never a good feeling. So hopefully this one doesn't disappoint. My goal is to get through this a little bit quicker so the video is not quite as long. I'm anticipating that we have some time to go over this in class, but this could be a refresher course, and I'm thinking at the end I'll probably do a homework problem. So if you put up with this video long enough, or just figure out how to skip forward quite a ways, you can probably get a free homework question out of it. This one I did cheat a little bit. I had to plan this one out because this can be kind of a confusing section, and I wanted to make sure it was clear. So you should all have a copy of these notes. I actually want to skip example 1. For whatever reason, example 1 is the hardest one to do. So we're going to start with example 2, we'll go to 3, and we'll come back to 1, because 1 has some problems with it. So the idea of solving equations and inequalities in two variables is that we come up with what are called some constraints. Okay, these are inequalities involving two quantities of unknown value that we can then graph and then solve graphically. Okay, so example 2 says for his math grade, Carter can do homework packets or math projects. He estimates that each homework packet will take 9 hours and each project will take 15 hours, and that he will have at most 120 hours to spend. He may turn in a total of no more than 12 packets or projects. Okay, I'm sorry. That just sounded terrible. That a 15-hour project and a 9-hour packet's not bad, but I don't know. That just scares me. So first thing we have to do is define some variables. Now you might have noticed on the homework we've given you what the variables are, but here in the example we haven't. So looking at this, it looks like my variables I'm going to want to look at homework packets and math projects. Okay, so you can pick X and Y, that's a pretty safe choice, or you can pick letters that more represent what they are. Since we're going to be graphing on an XY coordinate grid, I'm probably going to go with X's and Y's. So I'm going to say let's have X equal to the number of packets, and I'm going to have Y be equal to the number of projects. Now even though I've labeled them here, it's a good idea to label them on your axes as well, just so when we're graphing some things you can keep it straight. So I'm going to put down here number of packets, and here is number of projects. Okay, so now we need to come up with some constraint equations from what the story has told us. So it tells us that the packets take 9 hours, the projects take 15 hours, and he will have at most 120 hours. Okay, that at most tells us what our inequality is going to be. So I know that for every packet it takes him 9 hours, so that's 9x plus every project takes 15, so 15y is at most 120. So that translates to less than or equal to 120. So 9 hours per packet, 15 hours per project. We multiply the number of packets or projects we're doing by the amount of time they take, and all of that combined needs to be less than 120. Okay, that's one of my constraints. The other constraint, though, says he may turn in a total of no more than 12 packets or projects total. As a teacher, that just sounds terrible to grade all those. So the moral of the story is pass your classes the first time. But what we can say is that x plus y can be no more than, so again, less than or equal to 12. All right, remember x and y were number of packets. We had to add the 9 and the 15 to bring in time. So that's why it's okay just to add x plus y and say that's less than 12. Now, here's the trick to graphing these. We could do a bunch of algebra, and we could try and isolate y and have an inequality with y on one side, everything on the other, graph it like we normally would. But that might get a little bit complicated and take more time than we actually need. So the trick here is that we pretend they're equations, just for a second, and we set one of the values equal to 0. Basically, I want to find my x and my y intercept for each equation, and then since I know that I'm adding these things, I know that they're linear. Okay, I'm not multiplying two variables, I'm adding variables. So I'm guaranteed a straight line. So what that looks like is, okay, so these are my constraints right here. I'm going to box them off. Let's start with a simple one. X plus y is less than or equal to 12. Okay, if I pretend it's an equation and say let's set x equal to 0 plus y has to equal 12. Okay, this would be my line. Well, then what does y have to be? Obviously y has to be 12. I'm going to go with some colors here. Let's say this is my blue equation, inequality. Okay, so y has to equal 12 when x is 0. So let's come up here to 12. There's my y-intercept for that function, or for that inequality or equation, since we're kind of blurring the line here. Alright, and then on the other side, if I have x plus and I make y equal to 0 equals 12, well then obviously x also has to equal 12. So let's come over here. So those are my two intercepts. Again, I know it's linear, so I can take a ruler and these should go, there we go. Connect them. Now I should have made mention before I did that line that when we have less than or equal to, we do a solid line. If it were just less than, we would do a dashed line to show that we're not including the boundary, just like the open and closed dots that we've talked about before. Okay, so now the part that makes this an inequality is that we want everything that's less than this line. So we're actually going to shade, and this is where we go back to the inequality. We're going to shade everything beneath the line. So that's everything in this section. And this is where colors pay off, honestly. Doesn't have to be too dark, just so you can tell it's less than. Alright, now on the next one, I'm going to make this red. We're going to do the same thing. So let's pretend that x is equal to 0. So 9 times 0 plus 15y equals 120. So that's gone. I need to solve for y, so I could divide by 15 and let's see, 120 divided by 15 is 8. Okay, so when x is 0, y has to equal 8. So let's come up here and put a y-intercept right there. And then let's do the other one. 9x plus 15 if y is 0, if that were to equal 120. Okay, so that's gone. And then 120 divided by 9 is 13 1/3. Actually, I did that in my head earlier. I should probably check that. You know, since you guys don't call me on my mistakes here. 120 divided by 9. Ah, I was right. Okay. So we're just going to estimate. So that's 12, 13 1/3. Alright. So once again, linear. Connect the line. And again, we're less than. Our inequality is less than or equal to, so it's a solid line. And I can shade everything under this. Okay, so my solution area is where both of these are true. Okay, and so you can hopefully see from your colors this area where they're both shaded. And so try and find some way to denote that, like make it darker or shade it darker. I'm going to try and outline it here with purple. Okay, and that is my answer. Okay, so what it's saying is that any combination of x and y that falls within this purple shaded region will give me values that satisfy both equations. Okay, the ones up here in the blue just satisfy the first equation that I did, the blue equation, but not the red, and likewise over here with this little red area that I neglected. Okay, but both of them are satisfied in there, and that's your answer. All of your answers are graphs. Okay, they're all graphical this time. So, clear as mud, right? All right, let's go to number 3. All right, now this one is interesting. So here we have just one short sentence, or two sentences, I guess. The perimeter of a rectangle is at most 26 meters. Its area is at least 30 square meters. Okay, so watch out for the at most and the at least. Okay, those are opposites, so therefore the inequalities need to be opposites as well. So they didn't give us any formulas, but we should know that for perimeter. Okay, we know that perimeter is equal to 2 times the length plus 2 times the width. And we also know that area is length times width. But we know something about the perimeter, that it is at most 26 meters. So I can use 2L plus 2W at most. So that's going to be less than or equal to 26. And then my area is at least, so that's going to be the opposite. Length times width needs to be greater than or equal to 30. And there's my constraints right here. Now, we have one of these, call this the green equation. Let's start with this one, because this one is linear again. We're adding two variables. Okay, so pretending that we have an equation this time, 2L, let's say that we set W equal to 0, equals 26. That's gone. When I divide by 2, I get that L equals 13. So I have, oh, my bad, length and width. Call this one length, call this one width. Alright, so L equals 13, which of course is not on the graph that we provided. Why would it be? That would be too simple. Okay, 11, 12, 13. We're up here. So I know I'm going to need this one over here too. $13, right there. Okay, and hopefully you can see, and for the sake of time, when I set L equal to 0, I'm going to get the same thing on the other side. So I'm also going to get the W equals 13, or my W intercept. So there we go. Nice straight line. It is less than or equal to, so we can make it a solid line. And yes, those lines would continue on, but in context it doesn't make sense to have negative length or width values, so that the line can just stop right there. Okay, now the other one is a little bit trickier. Nope, not Thanksgiving yet. Can't use red. Wouldn't want to be accused of celebrating Christmas too early. Okay, now this one is no longer linear. We have two variables multiplying each other. So this is going to give me some form of a curve. Now you could type this in, like you could solve for one variable, divide by L maybe, and solve it in terms of W, or maybe vice versa, because that would be the Y. That's one way. I want to look at it just a little bit differently again, so we can do this by hand. Let's think about just some points. Let's again think about length times width equals 30. And what are some easy points that we could graph that satisfy this equation? Which is basically the same thing as saying factor 30. Okay? I mean, I can make it, let's do a list here. I could do 2 and 15. I could do 3 and 10. I can do 5 and 6. And then since they're on different axes, these are different points. Okay, 6 and 5, 10 and 3, 15 and 2. Okay, so these are a bunch of points that I could plot and then just kind of connect the dots. And I think we will do that instead. So 15 is not on the graph. Let's eyeball that. 14, 15, and then over 2. Oh, well, I totally did that backwards. Okay, my W's are my X's. So let's go from the bottom up. I hope you understand what's going on here. So I have a point at 2, 15, but this thing is symmetrical. So if I have 2, 15, I also have 15, 2. So let's come out here. 15, 2. Then I've got the 3, 10 and 10, 3. So 1, 2, 3, up 10, over 10, up 3. Then I've got 5, 6, and 6, 5. 5, 6, 6, 5. Now that doesn't look like much, but it is curving. Hopefully you can see that. And we're just going to connect the dots in a nice rounded curve. Yeah, that was pretty good. Alright, now I realize just now, once again, you didn't catch me, that I got ahead of myself and I never shaded for the green function. Okay, I want everything less than this line, so that's everything less than the green, and I mean this is perfectly fine for shading. And then I want everything greater than the blue, so I'm going above that line. We'll go a different direction maybe. Alright, and so altogether I get this nice area, and let's just pick a color that is totally different. Oh, that's lovely. That's terrible, but you get the idea. That weird brownish orange area is what satisfies both of them. Excuse me while I'm dying. Alright, so there's those two. Let's go back to number 1. Okay, I remember number 1 from last year. I had a big fight with it, and initially I lost, and then I figured it out. So this time I'm coming out on top from the beginning. So you read this thing, and there's a couple problems right away. So the Sweet Tooth Candy Shop. Alright, problem number 1 right here. That is not how you spell shop. Okay, I don't care that you're trying to be fancy. You know what? Some of us struggle with English as it is, and we really don't need your extra 2 letters. If you're going to add those, it is shopé, not shop. So it is the Sweet Tooth Candy Shopé. Is purchasing a candy mix with 2 types of chocolate, dark and white. Okay, problem number 2. White chocolate is not real chocolate. Alright, I love chocolate. Now, white chocolate comes from like the cocoa butter and the fat and stuff. And so I'll give it first cousin status, but it does not belong in the chocolate family. Okay? I mean, the only thing, you know, I don't want to insult anyone who likes white chocolate, but it does not belong in the same class as dark chocolate. But, you know, people who spell shop with an extra PE probably don't know that, so I guess they need to learn. So they need at least 180 pounds of dark chocolate and 90 pounds of white. Their supplier has 2 mixes for them to buy. The deluxe mix costs $10 a bag and has 4 pounds of dark and 1 pound of white. The plain mix costs $5 for a pound of each. The Sweet Tooth Candy Shopé can pay at most $800 for their chocolate. Alright, lots of things going on here. The first and probably most difficult part is identifying what your variables are and what you're really trying to solve for. My initial thought was to make the variables the dark and the white chocolate, like their number of pounds. But the further you go down that road, you'll find that it doesn't work, but you can also tell that one of my constraints you can easily tell is 800. So I need something to add up to be less than $800, sorry. So if I'm just adding, you know, dark and white chocolate in pounds, it's going to be really difficult to constrain that with money. And yes, we can relate them, but I don't know, I can't isolate these 4 pounds of dark chocolate and say exactly how much they cost out of the 10 as opposed to the 1 pound of white, and vice versa. I mean, no one ever said that it's a 50-50 split. If I get a pound of each and they're $5, well, I don't know if it's a 50-50 split. I really don't. So that leads us to go a different direction. What I'm going to do, and what we need to do, is define our variables as the deluxe pack, so the number of deluxe mixes and the number of plain mixes. And you'll see how that works out here. I do want to stray just a little bit from my x and y. I want to use D for number of deluxe mixes. I'm going to use P for number of plain mixes. Okay, so here's what that allows me to do as far as constraints go. The first thing I know is that for every deluxe pack I buy, I'm paying $10. So I can say 10 times D plus, and I know I'm paying $5 for every plain mix, and I know altogether, oh, sorry, that has to be, they can pay at most, so that has to be less than or equal to 800. Okay, so now I've worked in that money, and 10 and 5 are also monetary values. Okay, so everything works out here. But then I got to think about my other constraint, and those are that I need at least 180 pounds of dark chocolate and 90 pounds of white. So really, I'm going to make two constraint equations here. One focused on dark chocolate, the best chocolate, and one focused on 90 pounds of the other stuff. Okay, so what I know is that there are 4 pounds in every deluxe pack. So I'm going to do 4 times D for deluxe pack, but this is for my dark chocolate, plus the 1 pound of dark chocolate in the plain pack. I need that to be greater than or equal to 180. Okay, so I'm going to mention out here, I'll make this one red, but this is for my dark chocolate spelled with an O. Right there. Okay. And this, I should probably mention, is my cost. So I need another equation for the white chocolate, I guess. So in every deluxe pack there is 1 pound of white chocolate. So if it helps keep it clear, you can put 1D. Ha ha ha. They broke up. Get over it. Plus 1 for P for the plain pack. Okay, and I need that to be greater than or equal to 90 pounds altogether. So this is white chocolate. Okay, now getting there is the hardest part, and so if you don't quite follow it, maybe rewind, watch it again, come talk to me. Okay, but especially since we didn't tell you what the variables should be, that one can be a little tricky to get to. So let's graph this stuff. Okay, again, we're going to pretend like these are actually equations. We're going to find the intercepts for each of them. So for my cost function, if I set D equal to 0 plus 5P equals 180, okay, I would need to divide 180 by 5. 180 divided by 5, and you get 36. Really? Yeah, you do. Okay, so P would need to equal 36. I ought to set up my axes here. Hopefully you kind of notice that you're going to get more dark chocolate per pack than you are going to get for white chocolate. So I'm going to need to buy less packs to get more dark chocolate. So this is going to be my dark chocolate axis. and this is going to be white chocolate, because they're different. Even though it looks like a square, the scales are different. I'm going to have to buy more packs of things to get higher quantities of white chocolate. So that tells me I need my scale to go higher. Alright, so this is, well, let's solve for the other one. If P were equal to 0, I'd have 10 times the deluxe pack plus 0 equals 180. So D would equal 18. Okay? So let's plot these for the blue. So 18 is about here, and then P is equal to 36. What are these going by 20s? Oh wait, so 36-ish. Why? What am I looking at? You know, I even wrote this out, and I don't know what I'm looking at. Okay, this needed to be 800. I just shouldn't even plan. It just goes the same regardless. So, yeah, when I do 5 divided by 800, you get, no, 800 divided by 5, you get 160. Oh, okay. This was scaring me. It wasn't working out. Alright, and then 800 divided by 10, you get 80. Yay! That's much better. Okay, 80. Ignore these guys. And 160. Whew. You know, I planned it out, but I haven't looked at it once. That might help. Okay, and again, greater than or equal to, less than or equal to, solid line. Cool. Alright, let's try and speed this up a little, and I know I'm going a little long. Alright, so again, if I set D equal to 0, so I get 0 plus P equals 180, well then P has to equal 180. And then on the other side, 4D plus 0 equals 180. If we divide by 4, you get the D is equal to 45. Right? Yeah. Okay. So let's plot these. So D at 45. This scale is by 10, so 45 is right there in the middle. And P is up at 180 here. Connect them, and I feel like I'm passing my bad habits on to you, because once again I've forgotten to shade as I go. Now if you have different colors, it's easy enough to go back and see which equation goes with what, but if you're doing this all in pencil, you probably want to shade as you go. So I know that I need to be less than this blue line. Okay. I also need to be greater than the red line. Alright, and then we got one more, we got the green line to go. These ones are pretty simple. If you set one of them equal to 0, you get 90, the other one equal to 0, you get 90. So D equals 90 and P equals 90. Alright, so let's go, 90 is going to be right in there. Over here, 90 is way out here. I don't like that they made two different scales, but it is what it is. Connect them up. And I need to be greater than this line, which is a whole bunch of stuff. It's like everything, which doesn't make a lot of sense, but I guess, you know, to get that white chocolate you gotta buy a lot of stuff. But the only place that is overlapping in all of them is this little triangle area. So let's try purple again, since that highlighter failed miserably. And I just need you to darken it enough that I can tell the difference and that you know where they overlap. Okay, that's my solution area. Okay, that's all there is to it. Your answers are just graphs, so there's nothing else that needs to go with it. All right, hopefully that helped clear up a couple of things. I promised a homework problem. I know this video is getting long, so let's find one of those. Ta-da! Found it. I was kind of looking earlier, and I liked 7. So let's do 7. Cohen, which is a cool name, sounds very like medieval to me. Anyway, is about to take a test that contains short answer questions and word problems. Cohen must solve at least 5 short answer questions, but time restricts solving more than 10. He must solve at least 3 word problems, but time restricts solving no more than 10. Cohen can solve no more than 18 questions in total. Now, on the homework, you've got these nice little things that say let x equal this and y equal that. Perfect. All right, x is the number of short answer questions and y the number of word problems. So we actually have 3 things going on here. We have a lower and an upper bound for short answer questions. Okay, so I know that 5 is, he needs to at least, okay, so that's less than or equal to x, but he can solve, the time restricts solving more than 10. So he needs to be less than or equal to 10 on the short answer. Okay, and I'll show you how that graphs in a second. So for y, same idea. So for word problems, he must solve at least 3, but no more than 10. So again, 3 less than or equal to y, less than or equal to 10. And last but not least, altogether, he can solve no more than 18 questions total. So I need x plus y to be less than or equal to 18. All right, that's my system of inequalities that models my constraints. All right, so with this, you get to pick your scale here. I guess we can just go each as 1 if you want to make it small, or every other one. I don't know how. Let's see, 5, 10, 15, this is 20. Okay, let's do that. And 10 and 20. You are going to need to show me your scale, but you don't have to label every one, maybe every 5. Okay, so when it says that x is between 5 and 10, what that means is, think about the line x equals 5. That's just a vertical line at 5, and a line x equals 10 is a vertical line at 10. So I am bounded between these 2 constraints. Okay, so I'm just going to trace this line here at 5 and 10, and we'll mark this as being red. Alright, now same thing with the y. If you think about y equals 3, that's a horizontal line down here at 3. 1, 2, 3. Okay, so I need to be above that, but less than 10. Alright, kind of hard to see with the colors, but so I should do some shading now. I want to be between these lines, so I'm in there, but I also need to be between these lines. Alright, and the last one, x plus y needs to be 18. So going back to what we did in the notes, if you set x equal to 0 and pretend it's an equation, then y must equal 18. If you set y equal to 0, same thing, x must equal 18. So my intercepts are going to be at the 18s. and I have to be less than that. So that's this area. And so now that it looks like my pens threw up on my paper, we need to find their intersection. And so it's not just the square, because we've cut off a little corner. It's in here. Got this diagonal. Oh, I gotta come all the way down here to 3, don't I? This gets kind of tricky with pencils, so if you have colors, it's helpful. Alright, there's my solution area, and I'm done. Alright, good luck. I feel OCD and I need to put these on there, even though you know what I did. Alright, trying to have too much fun. Let me know if you need any help, and good luck.